Last day we just talked about how to calculate the molar mass of elements or compounds. But now we're going to have a larger application of this. So scientists often convert between mass of a sample and number of moles. Because when you go out to measure samples of chemicals, there's not a scale that's measured in moles. There just isn't. Every scale that you use is measured in grams. So you need to be able to convert from moles to grams. So the following formula is used in order to do this. So big M is equal to little m divided by n.
Little m?
Yeah. Now if you want to, you could write your little m as kind of like a cursive so that you can see the difference. Like if you can't see the difference between your big M and your little m, you need to do something like, I don't know, like write it like a, I don't know, a cursive M or something, just to make it look a little different. Okay, so you need to be able to work with this formula in order to rearrange it. So we can set it up like a triangle, kind of like we did in physics. So if I set this up as a triangle for rearranging, what goes on the top? Little m, yeah. Little m goes on the top. So remember, the thing that's on the top of the fraction goes on the top of the pyramid. Okay? And then we have our big M and our little n. Well, I guess there's only one n. So if we were to rearrange this, say I wanted to solve for n. You cover up n, and it's the little m divided by big M. So n is equal to little m divided by big M.
So what does n stands for?
We'll go through that next, but I just wanted to show you how to rearrange them all first. And then the last way to rearrange, if we were looking for mass, or little m, it's big M times by n. So then Joshua asked a great question. What do these letters stand for? So the number of moles of a substance, that is n, is number of moles. The mass of the substance, oh, and also the units for moles is just MOL. That's the units for moles. The mass of the substance is little m, and the units are grams. And then the last, by process of elimination, as well as yesterday's lesson, or 2 days ago lesson, we should know that the big M is the molar mass, because that's what we already did, right? We've already been calculating the molar mass of stuff. That was what we did last time. So what are its units? Because we already did that one. Grams per mole. Yeah. Now, a little point of interest is, look here, mass is grams and n is moles, so grams per mole. So when you look at the fraction, that should make sense. Now, in your data booklet, when you got, you know, for physics, when you had your data sheets and stuff like that, in here, this formula is in here, I think. Oh, okay. So underneath of your solubility chart, so actually get out your solubility chart, because then you can highlight where it is.
So when you're writing like if it's 5 moles, you would write moles M-O-L-S? Or would it be M-O-L-E-S?
No, you just write it as MOL. It's like the unit. Because like if you have more than 1 gram, you don't write GS, you know? Yeah, so it's almost like think about it as like just a unit. Yeah, not like a word. Okay, so on your solubility chart, underneath it says stoichiometry and solution formulas. Stoichiometry is something that I won't teach until Chem 20, but the little formula there, it says N equals little m over big M. So it shows you this version. And then it even tells you on the right-hand side what N means, what little m means, and what big M means. So if you forget, you have this available to you and you can look at it. So, you know, in science sometimes it's not about, yeah, we do have to do some memorization, but if you have a tool available for you, make sure that you remember that you have it there, you can use it, okay? And also, I will give you Avogadro's number on a test too. You won't have to memorize it, but after listening to that song, you should probably have to memorize it. Okay, so how do we use this? So this is an example. How many grams are in 2.5 moles of manganese chloride? Okay, first step, write out what you're dealing with. Pardon? So manganese, so let's find manganese on our periodic table. It's not magnesium, it's manganese. Oh crap, okay. And how do we know which ion charge to use? Because there's two. Well, they didn't tell us. The most common one, which is 2+. So we're dealing with manganese 2+, and chloride is Cl-. So then our compound is MgCl2. Hi.
It's Mn.
Oh, right. Thanks. It's Mn. I even said we're not doing magnesium. Thank you. Sally. Okay, and then let's write out everything, well, okay, so now that you have your compound, the next step is to calculate the molar mass. So the molar mass, so when we calculate molar mass, how many MNs do we have? We have 1, and its molar mass is 54.94. So obviously times by 1 is 54.94. And then we have 2 chlorines. And each chlorine is 35.45. Should put the units there, grams per mole. And what's our chlorine then? That's 70.9? Okay, so then you total it up. What's our total? Yeah, go ahead.
I got 125.84 grams per mole, or it used to be grams.
Grams per mole, 125.84 grams per mole. Okay, so then if this is grams per mole, what we just found was big M, right? Just like we did before. That was like our lesson from the other day. So we still have to do that step. Pretty much for all these questions you have to do that step, okay? But then we were given another piece of information. We were given how many grams are in 2.5 moles. So moles, that was little n, or just n. So n is equal to 2.5 moles. And I'm looking for, when it says how many grams, you need to think, okay, what is in the units of grams? So I'm looking for m, my mass. So little m is equal to question mark. Go ahead.
So you would use the triangle.
Yep.
And M would actually end up being big M times N.
Good. Am I just writing big, or are you guys running out of space too? If you want to, you know, do you have a back side of this, of your notes? Do you have right? You have a whole bunch. If you want to take up the rest of the space to do example 1, and then on the back side we'll do example 2 if you like more space, okay? But I'll take a note, I'll make it larger for next year. Sorry about that. Okay, so now we can just plug in our information into this formula. So little m is equal to big M, 125.84 grams per mole, multiplied by 2.5 moles. So I'm still doing example 1. I just moved down. All right, so what do we got? 3 what, sorry? 314. Was there any more? Decimals?
No.
Oh, okay. All right, so then good question. So it's like grams per mole. So if I was to rewrite it, it would be like grams per mole. So then the moles cross off, and I'm left with grams, which makes sense because a mass is measured in grams. Okay. So now, now what we have to do is we have to look at our significant digits. So we look back at the question, and the question had 2 significant digits. So we have to rewrite this in 2 significant digits. So then m is really 3.1 times 10 to the power of
What's
2,
your point?
because I won't round up.
And then you have to put grams.
Yep, and then your units in grams. Yes, please make sure, even when you're doing your work, you write your units in so that you can stay consistent. So then this would be our final answer. Okay. Any questions on that first example? Okay. All right, let's do example 2. So if you want more space, you can just flip it to the other side and you can write it out together. All right, so how many moles are in 50 grams of sodium carbonate? So first, you got to figure out what sodium carbonate is. So sodium was Na plus, and carbonate was CO3 2-. So when we crisscross, we end up with Na2CO3. So now what you can do is you can find your molar mass first, right? Once you figure out what compound you're using, you find your molar mass. So for my sodiums, I have 2 of them. And sodium is 22.99 grams per mole. And I have 1 carbon. And I have 3 oxygens. Now that we have kind of the individual parts, we can add them all up. We got 105.99. Do you agree? And our units are still grams per mole. So what we just calculated then is big M. So just remember, whenever you're taking the numbers from the periodic table, to calculate for, you know, how much a compound is, that's the molar mass of the big M. So then in our question, we were given 50 grams. So that's my little m, is 50 grams. And I'm looking for n, is my question mark. So then you can look at your triangle, or just what we wrote down. And we said n is equal to little m divided by big M. So then we can put in our values. So n is equal to 50 grams divided by 105.99 grams per mole. I get 0.472 moles. Did you get that? And actually, that's in significant digits already, so that's nice.
So what would the question look like where you had to find the big M?
Well, you won't really, because it's always given to you on your pure out table.
Yeah.
However, sometimes I do sneak in a bonus question where you have to find big M, and I've given you the moles and the grams, and you have to figure out which element it is. Because if then, go ahead. If you're finding the molar mass, then you can figure out, if it's just one element, then it's easy, but if it's like a whole compound, that's kind of
But
impossible.
you won't found a compound?
No, that would be crazy.
Okay.
That's crazy tough.
If you know your triangle, it's just that,
No, but just once you find your molar mass, like figuring out, well, do I add sodium plus carbon, or, you know, like, yeah.
Or how many?
Or just Google it.